What's up, everyone? Welcome to today's math lesson. We are continuing our study of area of polygons. Today, though, we're going to get a little crazy. Our polygons are going to become irregular figures. So grab a pencil, grab a calculator, get some paper, even your formula sheet, and follow along as we calculate area of irregular polygons. So our first example is on the screen. We are asked to find the area of this object. Now, this object is called an irregular polygon because its shape isn't one of the normal polygons we work with. Earlier this week, we talked about area of squares and rectangles and parallelograms, trapezoids, and triangles. Those are regular polygons. They are shapes that have a specific name based on characteristics that they have. Irregular polygons are a polygon because they're an enclosed figure, but they don't have specific characteristics that make them one of the regular polygons. And because of that, we don't have a formula that will calculate the area of a shape like this. So our only option is to deconstruct this figure, to break it into pieces that we can actually work with. So we want to look for a way to cut this shape into pieces that we can work with, to turn it into polygons that we do have a formula for. So probably the easiest way is to right here cut this shape into two different pieces. 1, 2. So if I cut right here, I create two rectangles that I can find the area of each. Starting with rectangle 1, I know it's a rectangle. Your formula for area of a rectangle, you always have your formula sheet if you need it. Area of a rectangle, length times width. So here's our rectangle. The length is 6 feet and the width is 3 feet. So when I do 6 times 3, I get 18 square feet just for this one rectangle. Now let's look at rectangle 2. Again, it's a rectangle, so I'm going to do length times width. The length of this rectangle is 5 feet times, now the width of the rectangle runs from this corner to where we cut at. So this is my width. And I need to find what that measure is. I know that this entire polygon from here to here is 10 feet. But we cut this chunk off. What is the measure from here to here? That represents the opposite side of this rectangle. So I know that this piece is 6. So 6 and what other chunk is going to give me a total of 10? Well, 10 minus 6 means that this piece is 4, meaning that this width of the rectangle is 4. So 5 times 4, 20 square feet for rectangle 2. So if rectangle 1 is 18 square feet and rectangle 2 is 20 square feet, to get the area of the entire figure, I want to add those values together. And you should get a total area of 38 square feet. All right, our next example, we have another irregular polygon. We don't have a formula that will allow us to calculate area of a shape like that. So we need to deconstruct this figure into polygons that we can work with. A couple different ways you can do it. The way I see, from this corner, we're going to deconstruct straight across. Down below, I get a rectangle. And up top, I get a trapezoid. Let's start with our rectangle. Area equals length times width for a rectangle. The length of this rectangle is down here. It's 8 times the width of the rectangle is 4. 8 times 4 gives us an area of 32 square inches for the rectangle. Now the trapezoid. I'm going to work my trapezoid formula over here. Formula for area of a trapezoid, if you need to look it up from your formula sheet, pull that out. Trapezoid area equals 1/2 times the height times the quantity of base 1 plus base 2. With our trapezoid, let's start by identifying our dimensions. I need a base 1, I need a base 2, and I need a height. Remember, the bases are the two sides that are parallel. In this case, it's the top and the bottom. I know this measure up top is 5. Base 2 would be this blue line where we cut the original polygon at. It doesn't have a measure, but it should be the same measure as the opposite side of a rectangle. And so if this side of the rectangle is 8, it means that this side of the rectangle is also 8. So base 2 is 8. Finally, the height of the trapezoid, the distance between the parallel sides. We know that this entire side of the polygon is 8 inches, but we cut it right here. Let's find this missing piece down below. It's going to match the opposite side of the rectangle, and this side is 4 inches, so I know that this piece is 4. So if this entire side of the polygon was 8 inches, and this bottom piece we cut off was 4, 8 minus 4 means this piece is 4 up above. Now, one thing to be careful of. I know if you look at these sides, they're both 4, but they don't look the same size. Most of these geometric figures are not drawn to scale, so you can't go by with just what your eyes tell you it looks like. We have proven geometrically that both of these measures are 4, even though one looks larger than the other. So let's take that 4 and make it the height of our trapezoid. And now we're ready to substitute these values into our formula. 1/2 times the height of 4 times the quantity of base 1, which is 5, plus base 2, which is 8. Order of operations, we're doing our parentheses first. 5 plus 8 is 13. 1/2 times 4 times 13 gives us an area of 26 square inches. Now remember, that's just the trapezoid. We still want to combine it with our rectangle from before. So 32 square inches for the rectangle, 26 square inches for the trapezoid. Combining that gives us a total area of 58 square inches. All right, I have one more irregular polygon on the screen. I want you to try this one on your own. Take a moment, draw this polygon with the dimensions, deconstruct it into pieces we can work with, find the area of each piece, and then re-add those total areas to get the area of this entire polygon. When you're done with your work, begin playing the video again to check to see how you did. Okay, boys and girls, let's check your work. Probably the easiest way to deconstruct this figure is to make a cut right here, because over here I get a rectangle, and on the left side I get a triangle. So shape 1 is a rectangle, area equals length times width. The length is 10, the width is 7, 10 times 7. I know that that rectangle has an area of 70 square centimeters. Now let's do our triangle. Shape 2 is a triangle. Formula for a triangle, we haven't looked that up today, so let's pull out our formula sheet if you need to. 1/2 base times height, your area for a triangle. Area equals 1/2. The base of this triangle is actually this blue line that we drew, and because it is part of the rectangle, I know opposite sides of the rectangle are congruent or the same. So that base has a measure of 7. And now the height would be the distance from the base up here to this opposite vertex. So we are looking for that height. Look, we know the entire polygon is 15 centimeters wide, but we cut that 15 right here. The piece that we cut off is part of the rectangle, and I know that that part is 10. So 10 and what give me a total of 15. 15 minus 10 means that this height up here is 5. So 1/2 times 7 times 5, you should get an area of 17.5 square centimeters for the triangle. And now we want to get the total area of a polygon, so let's combine these. 70 plus 17.5 gives us a total area of 87.5 square centimeters. Boys and girls, please complete your independent practice assignment for area of irregular polygons. Take a picture of your work and upload that file for submission. I'll see you guys next time.